Thursday, the 29th of October, almost done with the month. Geometry, SWBA students will be able to make translations on a graph, section 3.2, okay? So we learned about how there are transformations we can do on graphs. We learned about reflections in 3.1. In 3.2, we're going to learn about another type of transformation called a translation. A translation is to vertically and or horizontally slide a figure. It's to vertically and or horizontally slide a figure. It's very similar to cut and paste as far as like technology goes, okay? You take something and then you move that exact thing somewhere else. Okay? You're not changing the way it's rotated. You're not changing anything like that. You're literally just picking it up and moving it. Okay? Does that make sense? Okay? In symbolic form, because we've been doing these symbols, okay, x comma y, if you start with your original x comma y ordered pair, you're going to then get
X number, Y number.
x plus h and y plus k. H stands for, H represents the horizontal shift, because H for horizontal. And then K, of course, represents the vertical, because what else would you use for vertical, than K, okay? So K represents the vertical shift.
Wait, why do they use K?
Yeah, so I think it's because it's actually what you use for a circle for the left and right as well. And because V is typically determined to be velocity. So I think that's why they end up doing it that way. But I'm not entirely sure. I think that's why, though.
Dang you, velocity.
So H is the horizontal shift and K is the vertical shift. So we take whatever our horizontal is, we put it with the X. Why would the horizontal go with the X? Why would horizontal go with X? Because X runs left and right. It runs horizontally. Why would the vertical go with the Y? Because it goes up and down, okay? So we're not like putting like the horizontal with the Y. That'd be weird, wouldn't it? Okay. Oh my gosh. Okay. So we're going to practice. We're going to graph this rectangle QRST. So go ahead and plot the rectangle QRST. So Q would be at -6, -1. R is at -3, 1. S is at 1, -5. And T is at -2, -7.
Ooh, spooky. I'd rather be running with a folding chair hitting the ghost.
Okay, so then we have a rectangle. Our rectangle is tilted, isn't it? It's still a rectangle, but it is tilted.
But is it a square?
I just drew mine. I just missed it.
This one's not a square.
Completely wrong.
This one's not a square.
Yeah.
Okay, so go ahead and make adjustments to yours if you need to.
But they made it a fat rectangle.
What does that mean?
It's fat.
Like, did you draw it differently than mine?
A little bit.
Okay, it should be like mine.
No, it's like a little messed up line.
Okay, so make sure you have the points at the same spots I have my points.
You should be in the same
Sounds good.
spot.
All right. So now we're told if we have our normal x, y, these points, we're going to take our x and we're going to do what to it?
Add 5.
And we're going to take our y and we're going to do what with it?
Add 7.
At 7. So I'm going to take all my x values and add a 5, meaning I'm moving at 5 to the what direction?
Right.
The right, because we're adding 5. Now, what do you think? Where do you think it would move if it was -5?
Left.
Probably left, because negative ends up being left on the number line. Positive means right. So if I take -6 and I add 5 to it, what do I get? -1. If I take -3, I'm just going to go through all the x's. If I take -3 and add 5 to it, what do I get? 2. If I look at the s,
6.
okay, 1 plus 5 is 6.
3.
And then I go to t, -2 plus 5 is 3. So those are my x values. I'm going to pause here for a moment. Okay, yep.
Will we ever write the other half of it or from the graph?
Are we going to graph the second one? Yeah, we will. Yeah, and I'll talk about how there's two ways to do these as well, just like before. Okay? Now, for the y values, we're adding 7. So let's go through those. For negative 1, back on Q, the y value of negative 1, we're going to add 7 to it, and we're going to get 6. The negative 1 plus 7 is 6, okay? I'm gonna have people raise their hand for this one. Raise your hand and tell me what 1 would become. Okay, Kenny?
8.
Very good.
8.
Raise your hand for what negative 5 would become. Gregory?
2.
Very good, 2. Raise your hand for what negative 7 would become. Okay, Seth? 0. So now we're going to plot these new points. So we're going to plot negative 1 comma 6, and that's Q prime. 2 comma 8, R prime. 6 comma 2, S prime. Sorry, I'll slow down. I understand I plot fast. T, 3 comma 0. Then we'll connect these. So does this look like we just took the blue shape, the one on the bottom left, and just picked it up and moved it to over here?
I guess.
To the top right? I think it does. Okay? Every point's still the same distance away from the other points. Everything's facing the same direction. Nothing changed except we moved it. And if we look at any 2 points like T and T prime, we moved it how far to the right? 1, 2, 3, 4, 5 to the right. And we moved it 1, 2, 3, 4, 5, 6, 7 up. So we just took this entire shape, moved it 5 to the right, 7 up. So let's say, Mr. Kossel, I'm not really jiving, okay, you guys don't say that anymore, okay, but I'm not really jiving with the way you did it as far as doing negative 6 plus 5, negative 3 plus 5. Is there a way I can do this visually? And I'd say, yeah. You take your graph, you take your R, for example, and you say, okay, I'm going to move 5 right and 7 right, and 7 up, because it's x plus 5, y plus 7. So I'm going to go 5 to the right, I'm going to go 7 up, and that's where my point is. And then you write it down. And you say, okay, for Q, I'm going to go 5 to the right, 7 up, and that's where my Q is. So on and so forth. Does that make sense how there's 2 different ways to do it? Now, am I saying you have to do a certain way? No, I really don't care which way you do. I just want you to do what makes sense for you. Okay? So if what makes sense for Presley is different than what makes sense for Quentin, that's okay. They're allowed to do it differently. Okay? As long as they both end up getting the same thing, I'm Gucci with it. Yes. What? Oh, no. Okay, questions on that one? I want you guys to try number 2. When you have it or have questions, raise your hand. I'm going to go and start graphing this. Okay? So, but go and keep working, Tyler. Okay? So, C at 2 comma negative 1. D at 7 comma negative 4.
Will the shapes ever overlap?
Yep. Sometimes. E at 4 comma negative 6. Third time's a charm. Got it that time. So then for my transformation, my x is going 3 what direction? Am I moving it 3 right or 3 left? For my transformation on number 2, am I going to move this shape 3 to the right or 3 to the left? 3 to the left because it's negative 3. So I take the x value of 2, move it 3 to the left, it's going to be negative 1. 2 minus 3 is negative 1. 7 minus 3 is 4. And 4 minus 3 is 1. I'm moving the shape 8 up, though, so I'm going to add 8 to the y. So negative 1 becomes 7, negative 4 becomes 4, and negative 6 becomes 2. So I can graph these points to graph the new shape. And we end up getting this new triangle. Do we have any questions on this one? Okay, give me a thumbs up if you're feeling pretty good about this. Thumbs down if you feel like you're not quite getting it yet. Okay? Thumbs up if you're feeling good about it. Thumbs down if you're not. I don't see everyone voting yet. Thumbs up if you feel good about it. Thumbs down if you don't. I see everyone voting yet.
You sound like YouTube.
Yes, yes. Give me a like if you like this video.
No, I don't like the voting thing.
Like, dislike.
They're badgering people to vote now. It's like, every time you get on there, somewhere, there's like, hey, have you voted yet?
Yeah.
Yeah.
I just say
All right. We're going to skip 3 and 4. We're going to skip 5 as well. We're going to go all the way to 6.
When you watch Optimus.
Okay? Now on 6, you might see these overlap. And that's okay. I want you to try 6 and raise your hand if you have questions or when you get it. Look around, saw some good things, okay? So, first thing is to plot this. So, negative 3, comma 6 for A. B is at 0, comma 7. C is at 1, comma 4. And D is at negative 5, comma 2. Thank you, Lauren. So we connect these, we get this trapezoid. Lauren, we're in our 3.2 section over translations, okay? We're finishing up example 6 right now. So we're doing the transformation, we're moving it 4 to the right, 1 down. So for our x values, we're going to add 4 to each of these, okay? So negative 3 becomes 1, 0 becomes 4, 1 becomes 5, and negative 5 becomes negative 1. Y values, we're going to subtract 1 for each. So 6 becomes 5, 7 becomes 6, 4 becomes 3, and 2 becomes 1. So to plot these now, we're going to have A at 1, comma 5. So A prime is there. 4, comma 6 is our location for our B prime. C prime is at 5, comma 3. And D prime is at negative 1, comma 1. So we connect these lines, connect these dots, and we get this new trapezoid. Same shape, same size, same everything. We just moved it. And these happen to overlap. Now, in like real life, okay, if I move this stool's right here, okay, right now. Everyone take a good look at where the stool is up front. Everyone take a good look at where the stool is up front. Okay? If I move it here, does it overlap where it was previously? Yeah, but you don't see where it was previously now, do you? Okay? But on this, though, just because we happen to have both drawn, you still see it, and so it looks weird. But we essentially did the same thing where I just kind of moved the stool like half the distance of the stool, okay? And so it still overlaps where it was, but doesn't change anything. Does that make sense?
Yeah.
Okay.
yes, when someone looks at you with evil intent.
What are you trying to say?
Oh, you said take a good look.
Ah, gotcha.
There is an evil look.
Yes, you can take a bad look. You just don't get a good look at it. It means the opposite. So let's go ahead and flip the page here. So we were taking a shape using a rule to make the transformation. So now we have the original shape, we have our new shape, and we're trying to make a rule describing the translation. How do we know which one of these is the original, and how do we know which one's the new one? Kenny?
Because the things have the apostrophe.
The apostrophes. The new one has the apostrophes. They're called the prime points. We have D, D prime, E, E prime, and F prime. So we said, okay, to go from the original to the new one, how could we know what we're doing here? Okay? Ray?
First of all, you would want to know the points of E, E, and F.
Okay, so it might be helpful to find our points D, E, and F.
You want me to finish?
Yeah, go ahead.
And then you can see how far the other shape is.
Yeah, you can see how far away the other ones are, right? Now we could do it 2 ways. Go ahead, what?
Or you could just figure out their points too, and then subtract.
Okay, you can do their points too and then subtract, okay?
Which point are you talking about?
So let's go ahead and try and find the points for D, E, and F. So what point do we think D is at? What point do we see D at?
-3.
Negative 3, comma 3. What point do we see E at?
2, comma 0.
0, comma 2. What about F?
-1. -5.
Negative 1, comma negative 3. Okay, what about the primes now? Okay, we got the originals. What about the primes? Where do we think, where was D prime at? What?
That's 5, comma 7. 4, comma 7.
4, comma 7. Where's E prime at?
7, comma 6.
Yep. And where's f prime at?
6, 1.
6, 1. Okay. So we can say, okay, well, what happened to each of the x values from the original to the new? We went from -3 to 4. We went from 0 to 7. And we went from -1 to 6.
We added.
Added? We added 7. It's probably easiest to see that one on the 0 to 7 one, right? Okay. We added 7. So if we're taking a rule, x comma y becomes x plus what? 7, because we went 7 to the right. And we did something to our y. Now, if we look at the shape, do we notice the y goes up or down? Up. So we should be adding something. And if we look at our points, 3 went to 7, 2 went to 6, and -3 went to 1. How much did we add by? We added by 4. So this is our rule. X comma y turns into x plus 7, y plus 4. You can also say yields, so to speak. As you plug in x and comma y, you will yield x plus 7, y plus 4 using this transformation. Now, is there another way to do it besides writing these points out? Okay, Seth.
There's regular things like the translation and reflection transformation.
What do you mean by regular thing?
Reflection.
Okay, yeah. So you're just saying it also could have been maybe a reflection here. Okay, this one, yeah, we just had the translation. Ryan, what are you thinking?
I need to go down to
Okay, Seth or Kenny, what are you thinking?
Alright, so you can count over and then up.
Okay, so if you pick any point, Kenny, which point do you want to pick?
F.
Okay, cool. From F to its corresponding point F prime, count over and then up. However many you count over will be however many. So, like I said, we can either count or we can write out the points. Personally, I prefer to count. Okay, you can do either, and they work, okay? But I prefer to count. Let's go and get our setup, though. We're going to have x comma y. This arrow means yield. So x comma y yields. And it'll going to be x and y doing something. So which ones are original? The one on the right and down, or the one on the left and up?
Right and down.
Right and down. How can you tell it's the original? It doesn't have the apostrophe. It's not the prime points. Whereas the prime points are to the top and to the left. So a lot of us got confused and switched which one was which. Okay? So you got to be careful there. That's why we label those prime points with the apostrophes. So that way we know which one's a new. Okay? So if we pick any one point, let's just say P, for example. And I say, well, how far does it change left to right? It goes left 1, 2, 3, 4. So it's x minus 4. We took the x value and we took it 4 to the left. And you can check another point too, O to O prime. We went left 1, 2, 3, 4. And same thing, M, same thing.
How many up?
How many up? Okay, let's check P again. 1, 2 up. O, 1, 2 up. N, M, same thing. So Y plus 2. Now let's say we did write out the points, okay? If you wanted to, you definitely could.
I can tell you the points real quick.
Okay, go ahead, Ray. That'd be awesome.
So for the normal M is 3, 3, N 6, 4, P 0, -7, O 6, comma, -8.
I disagree.
I don't think it's -8, but I think it's 6, comma, -7.
I disagree with all of them.
I get 0 7.
Yeah, P's at 0, 6, 0, -6.
0, -6, and not 6, 4. It's -6.
N is at 6, comma, -4.
3 is at M is at 3, -3.
And 3 is at M -3. Or 3, -3, yeah. Okay, so I'd agree with those.
My whole mirror switch.
What do you do if it goes off
Okay.
the board?
What?
What do we do if it goes off the grid?
It shouldn't.
But on 9 it does.
I have a feeling
No.
that one's not what we think it is, because I did it too, and I feel like it's really not what we think it is.
Okay, so
Not even there yet.
okay, so then for our transformation, what would we say what our new points are? So M prime, N prime, P prime, O prime.
N and O.
-1 for M.
Okay, -1, -1.
1.
No, I got 2. Yeah, 2 negative ones.
Okay, 2, -1 for N
I
prime.
got 2 negative 1.
N is
I got
2
2 negative 2.
You're right, 2, -2, thank you.
Negative 4, negative 4.
O is 2 -5.
Negative 4, negative 4. 2, negative 5.
Okay, so we can say how far apart are these? So you can say, how did I get from my original to my new? 3 to -1, I had to subtract 4. 6 to 2, I had to subtract 2. 0 to -4, I had to subtract 4. Okay, Seth.
The easier way is if you have one that has 0, you can just take that 0 and take it like p to 0 and 6. You can
Yeah. P starts at the x value 0, and the p prime, the x value is -4. That makes it a handy one. 0 to -4. Oh, well, 4. -4. Subtract 4. Okay. Questions on these and how you can do it either way. Give me a thumbs up, feeling good. Thumbs down if you're not. Okay. Moving on. These are going to be a kind of a combination. Okay. These are like a 2-step one. Okay. So we're doing transformations, plural. You have an A and a B. Which one do you guys think we'll do first? A, and then we'll do B. We'll do them separately. We'll do them as step by step, okay? So our first step, though, is to graph the triangle XYZ.
Oh, okay.
So we're going to graph the triangle XYZ, so -3, 7. -2, 1, yep.
We have to go for our pictures.
Alrighty. And Z is at -5, 2. Now, our first one is to do what? What's our first transformation? To reflect over the x-axis, okay? So here's what I like to do. I'm going to draw a dashed line over the x-axis like we did before. And we're going to reflect it over it. Well, we know the x values left and right isn't going to change. The y values are. So the point y is 1 away. So y prime will be 1 away. Z was 2 away, so Z will be 2 away. And X was 7 away, so X will be 7 away. Now I'm going to connect these using dashed lines. And the reason why I'm going to use dashed lines, I got really loud there. The reason why I'm going to use dashed lines here is because this is not our final answer. So this is our kind of a rough draft, like our working example. I'm going to go and put off to the side. Here's my X, Y, and Z and kind of my working example.
You didn't put them in prime.
You're right. Because the final ones are the prime ones. So these are kind of a working example. This is kind of like a rough draft for like a paper. Okay, you do your rough draft and then you do your final draft. Make some revisions. So this is like a rough draft. We're like part of the way there. So my dashed line X, after I do just the reflection, okay, is at -3, -7. My Y is at -2, -1. And my Z is at -5, -2. I'm going to write those off to the side. And now on the graph, I'm going to do a dashed triangle there. Okay? And once again, that's just because that's my work in progress one. This is what I get after I do step A. After I do transformation A, where I reflect over the x-axis, I get this triangle. But are we done? No. What do we still have to do? Translation. We still have to do the translation of x plus 9 and y plus 2.
Wait, I'm still confused.
Okay, what's up?
Why did we draw that dotted triangle?
Yep. Because we did this transformation. Now we're going to take this one that we reflected, the dashed one, and we're going to translate that one. We're not translating the original one, the purple solid one. We're going to translate the blue dashed one. Okay? So you do one change, and then now from this, you do another. And so I think it's really handy to graph it and write it down so that way you know what you're working from, okay? Questions on how we got to this point? So now we do the translation. So what am I doing with all my x values? Adding 9. So -3 would become 6. So my x prime is 6. -2 becomes +7. -5 becomes 4. So those are the x values for my new points. My final ones. What do I do with the y values? Add 2. So -7 becomes, -1 becomes, and -2 becomes 0. So these are my new prime coordinates, my new coordinates. So I'm going to graph these. X prime at 6, -5. Y prime at 7, 1. And Z prime at 4, 0. And I'm going to connect... Okay, I'll slow down. So I'll give you guys a second to catch up and graph those.
Yeah.
Sorry, I'm pretty quick at plotting those points. I forget you guys sometimes need a little more time. Thank you for telling me.
Yeah, you're throwing us in the dust.
Good call, good call. Okay. So I'm going to connect these points. And does it look like I just took this blue dashed triangle and picked it up and moved it?
Yeah.
Yeah, it does, okay? It doesn't look like I did that with the purple one. It looks like the purple one is like picked up, moved, and like rotated around, okay? Because we ended up doing two different transformations. Does that make sense? So really, we just kind of did two problems in one, didn't we? Bless you, must rain down after, let's forget. Do we know how to do each of those problems individually?
Yeah.
Yeah, we just put it together. We said, oh, we're going to do one, then we'll do the other. Give me a thumbs up if you're feeling good about that. Thumbs down if you're not.
I think this is what I did before.
Ooh, okay. I want you guys to try number 12. Okay? Same idea, but which one are we doing first now? The reflection or the translation?
Translation.
The translation. So I want you guys to try number 12.
So we have to do the translation first and then do the reflection?
Yep, on this one you have to translate it first and then do the reflection. So this time your translation will be kind of your rough draft one that we do in dash lines, and and then your reflection is going to be the final one. So if you haven't finished yet, go and follow along with me. If you have finished it and already checked you, ignore me for a moment. This is the one time I'll give you guys permission. So if I plot this triangle G, H, I, G is at negative 1, 6. H is at negative 1, 3. And then I is at negative 6, 6. Now we're supposed to take this triangle and we're supposed to first translate it. So I'm supposed to move it 7 to the right and 5 down. So my 7 to the right, I'm going to add 7 to each point. So I'm going to take my G, my H, and my I. And these are going to be like my rough draft copies. So G is going to add 7, so negative 1 becomes 6, negative 1 becomes 6, and negative 6 becomes positive 1. My Y's I'm going to do subtract 5, so 6 becomes 1, 3 becomes negative 2, and 6 becomes 1. So I'm going to plot these, okay? So once again, for anyone who has not finished this yet or not had it checked, this is for you, okay? So G, 6, 1, H, 6, negative 2, and I, 1, 1. And I'm going to do this in my dash line. That way we know it's the rough draft. And I'm going to do my final draft next, and we're going to reflect it over the line y equals negative 3. So we're going to take the one we did in the purple dashed, and we're going to reflect it over this line y equals negative 3, everywhere where y is negative 3. So we say, well, how far is each point away? H is 1 point away, so H prime is going to be 1 point away on the other side at 6, negative 4. G is 4 away, so G will be 4 away on the other side, 6, negative 7. I is 4 away as well, so I prime will be 4 away at 1, negative 7. And this is what we end up getting our answer to be, okay? Do we have any questions on this?